This is, I have to give a couple caveats. It's always bad when the speaker gets up there and they start by giving you a couple caveats, right? So let me start off by giving you a couple caveats. The first thing is that this is going to be a discussion with an opinion. And it's going to be slanted. So the reason I'm telling you that up front is because you may be sitting there saying, well, I think that what you haven't discussed in here is this aspect or this aspect or this aspect of some other architecture. And the reason I'm telling you that up front is because as I was charged to do this, looking at the global picture was not within my scope. The thing that was in my scope was basically go out and ask a very specific question, and then once I got the answer to that specific question, we came back and we put it into the answer that's like this. So that means that what you're probably going to say is, yeah, but, well, got it. Copy that, and that's a decision that you'll have to make, about evaluating these different things. But the thing that I hope that you get out of this is that you can see that there's an approach where in some places we hear sort of a broad brushing, don't we? We go out there and say, oh, everything is the same. It's just, you're going to call an API and something happens and all these kinds of things, and not trying to disparage on any of the other speakers that you may have heard here today. But the point is, when it actually comes to implementation, it really does make a difference. And if we're going to go out, and security is going to be one of our considerations, then we have to at least be aware or cognizant, even if it's not the desire of the architecture that we choose to do something, we at least have to be cognizant of the fact that we'll get this side effect or we'll get this detrimental effect if we happen to go with this particular architecture. So that's the first thing to keep in mind as we start going through those. So here was my charge. A number of years ago, we had, I come from the Brocade heritage, we used to have something called a Secure FOSS. I think that was the official name of it, wasn't it? The Secure FOSS. This was a version of the operating system that was intended to be a security product. That is to say that if you were going to go out and you were going to buy a switch, you could either buy one of our regular switches that had security features on it, or you could buy this hardened version of FOSS, which was a security product. It didn't just have security features, it was actually intended to be a security product. And what we found out in talking to people is everyone thought it was going to be a great idea, and I think it's fairly safe to say not that many people bought them. I mean, there were a couple things that happened as a side effect. In fact, I'm an old guy, so I have to tell you at least one old guy story. It turns out that I can remember the first time we got a secure version of Linux, the first thing we administrators did was lock ourselves out of the system. Because there were so many different things that you could turn on, and we did so, because should this be secure? Yes. Should this be secure? Yes. Should this be secure? And it turns out the problem came up when someone said, can you change the paper in the printer? And all of a sudden, we realized no one could change the paper in the printer, because no one could get to the print queue, because no one could get to the print device, because someone couldn't log in, because it just turned out to be a mess. So what happened is that we came to the realization as a company, we are not a security products company, meaning Brocade at the time. Now that is not to say we're not building products with security in them. And as a matter of fact, if you look at it, we were really innovative in building into our ASICs features that do things like encrypting links and automatic key exchanges, and we still continue to do those things. So we are a product that has security features, but what that means is if you look at security products, you won't find our name that's on there. So someone came along, actually my boss's boss came along, and said, we want you to investigate security as it relates to our products. And I thought that was pretty interesting. How do you do that? Because it's not a security product. So one of the approach that I took is I went out and I talked to y'all. I talked to customers and I said to them, have you noticed anything about our products that either make them more or less secure? And is there any kind of differentiation? And one of the things that came out is you all said, yes, there is differentiation. We have found that there are different security characteristics that can be associated with different deployment architectures. I thought that was kind of interesting, and so I got licensed for my boss to say, can I chase this for a little while, and he let me do that. So all that long introduction, should have had this on a disclaimer's claim, right? To talk about this security discussion that we're going to have right now. Oops. And this is the key that goes back. I push the red button. You never push the red button, right? You always push the green button. So I'll do that. So let me start about the abstraction that you may hear in a lot of automation discussions, a lot of product discussions. Basically, we have this abstraction today that says when you think of a typical application environment, it's simple. You have a program that has to run someplace, probably on some sort of processor, and then you have the data on which it operates. It's a really simple model, right? And we can take that simple model and we can abstract that onto a lot of different architectures. We can say, for example, it's going to run on bare metal, or it's going to run on a mainframe, or it's going to run in a container, or it's going to run in a virtual machine. But that abstraction is always the same. We're going to have some application that runs on some sort of processing element, and then we're going to have the storage upon which it operates. But then you come to guys at the next person, or the next level down, where they say, okay, we want to actually deploy that thing. Well, you can't deploy an abstraction. We haven't figured out how to do that. At some point, there still has to be a thing or an infrastructure or a platform that still gets deployed. And so today, as I was out talking to customers, they said there's 4 deployment models that seem to be prevalent. The first is the easiest one, right? This is just going to be where I'm going to have a processor that's sitting out there, and I'm just going to put a disk drive or something. I'm just going to hook it right up inside of it. Or for those of you who are familiar with the Optane technologies that Intel is coming out with, this is going to be very high-speed close memory. Some people have direct attach. It's not an array. I'm not going to go that far, but it's just storage. It's some type of storage that's direct attached. Pretty easy case. Second case is where I have this idea of containerized or virtualized infrastructure. Basically, in this case, there's some concept that says, I know that this process is using this disk drive, or these files on this disk drive. As I start to move to a virtualized environment, I lose that. Instead, what I'm going to say is, I have this virtualized processor, and this virtualized processor is operating on some data set that lives somewhere. But I'm not exactly sure where it's at because it's virtualized, right? For example, it could live on a local file system. It could live across an IP network. It could live across a fiber channel across network. It could live someplace else, but I don't know where that is. I mean, that's just sort of magically stuck in the middle. I just get storage. When the virtual machine or the container comes up, it can get to storage. The third piece of that says that the way that I want to deploy my storage is going to be that I'm going to have a local area network and I'm going to put my storage out there, but my storage is going to be addressable using IP. So I can actually go out and I can mount this storage. I can use iSCSI or I can use NAS or something like that, and I can make it appear logically that whether I'm using this abstraction or even this abstraction, I'm going to have some storage array that's sitting out there. And then finally, we get to the world that I live in, which is the fiber channel attachment, which is to say, not only is there a separate infrastructure for supporting the storage, but it's actually running something other than these standard protocols. So it looks like something else. By the way, in 2019, I'm not going to go down this path very far, but you have to be asking yourself, why is this stuff still around, right? This fiber channel stuff, I mean, every year we hear this fiber channel stuff is dead, right? So here's my initial knee-jerk reaction. This won't help me in front of my boss or anything. And I'm going to say, then quit buying it. Hock Tan, the guy who's in charge of Broadcom, quit buying it, and then we'll just go away. Well, why aren't you quit buying it? It turns out that architecturally there's reasons for that. And those reasons typically have to do with high-speed, reliable, secure infrastructure. Now, I said secure in there, so now the onus is on me to prove that, and that's going to be what the rest of this talk is going to be about. But what we've found out is, in spite of the fact that we're this relatively little teeny tiny piece of a company, we still do a lot of this. And the compelling reasons right now are something that are best left for another discussion. We won't get into that today. We're going to focus only on the security aspect of that. So let's chase that a little bit. What was the first thing when I talked to our customers to say, why do you think fiber channel is more secure? Or why do you think, let me roll back a little bit, network and storage is more general? So in order to find out this answer, I talked to a lot of you, but I did something else. That it turns out that I have a little bit of a history in academia myself, and so I went back and talked to some people who did y'all know what gray hat is? Some of they're really nice guys, but some of the fake bad guys. And I said to them, if I were to bring you into an infrastructure and say to you, I want you to go after this infrastructure, what would you try to get to? And one of the things that they told me that differentiates this is, if I put my processors or I put my storage, whatever is out here on this front line, whatever I can see by getting into this layer of the network, that's going to be what I attack. Because I can see that. I really don't have, unless I do something like human engineering or something like that, I really don't have the ability to do a lot of air gap attacks on things, or at least far distance attacks on things. But if I can get to it, I'm going to go after it, which is to say, if somehow I can figure out how to get inside of an infrastructure, anything that's out here is a target. Now, let's suppose that it's compromised. And here again, that's a big, well, Chip, you don't know our systems, and I'll give you that. But the point is, what do you get if you compromise this system? And that system can be compromised. I'll say this here now, but the same thing applies for a number of slides after this. Compromising doesn't necessarily mean bad guys. Compromise can also be incompetence or accidents. Anything that's going to cause the loss of the information that's going to be stored on this, okay? So in the future, when I say security or cybersecurity, I'm including accidental disruptions to that. If someone gets the ability to do this control plane in either a direct attached or a hyper-converged environment, they can do anything they want. They can get out there, and because this is the platform upon which storage is provisioned and managed, if I get control of this platform, I get control of these storage resources. If, however, I put a network between the two of these, then now, if I compromise this site, control plane access, and that's very, what I mean by control plane is the stuff that you manage. Thank you. The stuff that I manage is going to be, are you sure? Because we started at a quarter till. It's only 15 till. Okay, sorry. I'm enjoying my topic. So what this means is that I've now got this infrastructure that's out there that says, I can touch this, but I can't touch this. The other thing that's nice about Fibre Channel, it's a data channel. It's a data channel. I don't get control plane access to this thing through here. Now, I admittedly may lose this LUN, and I will compromise the information that's on that LUN. But in an environment where my entire infrastructure is based over here on either a direct attached or a hyper-converged environment, I can't see, or here where I can see everything, I can't see everything that's over here. I can only see those things that are in my control plane, and this stuff happens to be outside of my control plane. So what that means as a side effect is that if I have an IP-based controller that's sitting out there, that IP-based controller can be the target of an attack. Anything that's got an IP address on it, I can attack now. Because that means that assuming that I have that connectivity, it's a target. I can see it. And I can see that from what I'm going out there, as opposed to an environment that says, because I've got this weird proprietary network that's in the middle, not primarily for security, it's primarily there for performance, right? But as a side effect of that, I don't have a transport layer, which again means that my plane of control is going to stop with whatever I can see on the network. Which means that over here, if I have direct attached or hyper-converged or IP-mounted storage, I'm going to be able to see it, and I'm going to be able to do something to it. Even if that attack is nothing more than a denial of service designed to interrupt my data plane, in this environment, you can attack all of these, but down here, I have a separate environment. I don't have a path that can get through me. So let's chase that a little bit more. Out here, if I have those storage arrays that are going to be separate, this is a little bit different than the first point. That means that I do have a separate control plane, and as such, I can have a different kind of security policy enforcement sitting out there. So what that means is that if I have, let's say, my storage arrays that are sitting out there, and somebody gets one of those nodes, that means that even if that how can I say this? Even if that attacking element happens to migrate to another node, or the infected virtual machine or the infected container happens to move, I still have centralized control of my storage, which means, first of all, that I now have a uniform access policy across all the different nodes that are getting to it. So rather than thinking of all the nodes that are in my cluster, what that means is that presumably all the nodes in my cluster are in the same control plane. That's why it's a cluster. In this environment, if I happen to migrate to another entity that is completely separate, I still get the same enforcement of the policy because my policy is not being enforced at the access layer. It's being enforced on a completely separate entity. It's another interesting side effect that's over here. Again, not something that was designed, but it just happens to be another side effect that the storage is now operating inside of a separate control plane. So now let's assume that something has happened. Earlier on one of the panels, they were talking about the fact that we want to be able to look at the infrastructure to figure out if something has gone wrong. As a matter of fact, one of the panelists earlier today even made a comment to the effect of, oh, I want to know what it looks like on Monday, or I want to know what it looks like on Tuesday. So for those of you playing buzzword bingo who are wondering at what point in the presentation I'm going to say machine learning, guess what? Machine learning. And here's what we've found out. It turns out that because the I/O is now taking place on a separate platform. And I'll be the first to tell you, this platform may not be fiber channel attached. It may be IP attached, although it's harder because I have to filter traffic and so forth. But because there's distance between the processing entities and the storage, I can watch the traffic. I can watch the traffic. And I can learn from the traffic. And so earlier, remember the conversation when the gentleman was saying, if I have this traffic on Monday, what's normal for a Monday? By doing regression analysis, because I can now see the traffic patterns that are here on this infrastructure, I can now tell you this looks like a Monday. Or, and this is really useful, let's assume things are going to continue to grow, right? Because you don't throw things away. Let's assume that, I don't know, what's the curve look like? Does that look like a curve? You with me? You good? Come on, you're getting a free lunch. Just go along and say, yeah, that's a great curve. Okay, good. Okay, so that's a curve. One of the things that regression analysis can do is say, that looks like a normal curve, but if I elevate that a little bit, that's still the same curve. I'm still seeing the same behaviors, I'm just seeing it with an increase of data. But if somehow I see some sort of inflection in my data curve that looks different, I can come back and I can say something like, there's a denial of service attack going on here. Or someone is trying to get desperately to the storage array, which can either indicate I've got an error and I've got an application which is offline, or I've got somebody trying to have a denial of service attack, or I have somebody who's trying to break in to try to get access to that data. Because I can see the traffic that's going back and forth. Now, there's a lot of other reasons that I want to get information out of this infrastructure, having to do with analytics and growth and planning and those sorts of things. But from a security viewpoint, this is really neat. If I go into an infrastructure, and I even have someone who, to use an example, if somebody starts up a torrent, you all know what a torrent is, right? Don't pretend you don't know what a torrent is. Everyone knows what a torrent is. If you start up a torrent, I'll see it because of the way torrents access that infrastructure. And that's going to show up as an anomaly. Now, one of the pieces of that says that in order for me to detect the anomaly, I have to be able to capture the norm. And the way that I capture the norm is I have to be able to do the analytics. There's one other point that I want to make here before I move on off of that. And that is that a lot of people are really nervous about the fact of saying, Chip, the information that we're moving back and forth, we have complete data opacity. We don't want people to be able to see what's part of the payloads. That's okay, because it turns out for the type of analytics that we're running in here, we're not looking at the data. We're just looking at the behaviors of the data. We're looking at the metadata. And from that, we actually have enough to be able to tell something like, oh, this virtual machine that was living over here, it's just migrated over here. And I know that because the signature of the IOs that was taking place on this virtual machine is now present over there. So we either had a migration or we had a failover or something happened. I can remember that one time there was a story I was reading on the web about somebody who started using this type of regression analysis because they could see this data, who thought their company was under attack. And what had actually happened was that the people who were provisioning their desktops went from the versions of the Microsoft Office apps that actually live on your desktop, they started going to O365, which meant it was going to be getting web access. And one person did this, and then they said, we're going to sort of bring this in to make sure that it works. As that happened, it looked like an infection that was taking place because we are seeing the behavior characteristics of each one of these nodes changing. And the important part about that is we saw the change. We got the analytics, and we could see that. Oh, I lost the thing. We could see that. Thank you. We could see that because we had the visibility to it. Otherwise, to do it in direct attached, it's hard. I either have to depend on counters to do it, but you know what? I can turn off counters. I mean, before I was doing this stuff, I was doing operating stuff, and I can turn off any piece of any utility that you want me to inside of a kernel. I mean, you can just do those kinds of things. In this environment, traffic's traffic. At some point, something has to get from up there to down there, and this gives me the ability to do it. The other thing that's interesting is if you were here for the discussion, the panel discussion that was held at the beginning of this session, there were 3 different vendors that were sitting there, and one of the things that's really healthy for y'all as customers is that each of those 3 people that are up there is representing a different set of commercial interests, although their business interest is the same, which is providing you something that you want. So what that means is that their job is going to start saying, can we put some sort of advantage inside of that external storage that we're providing that wouldn't ordinarily be present if this were going to be direct attached or if it was just in a cluster or something, because I don't have anywhere to wedge any value in. Now, there's other kinds of features that are in there. For example, like this, misbehaving devices, optics and cable testing, bit corruption recovery, those sorts of things. But the important thing here is that another aspect of what they can do is also provide the security that comes in there. And so they can do things in the background. For example, they can do virus scanning, or they can look for peculiar attacks based on characteristics they're seeing in the file system that they might not have a chance to see if this was directly attached storage or if it was in some sort of cluster where, again, I didn't have the capability to bring these in. So the point here is that these external vendors now have the opportunity to innovate, and the platform for innovation isn't in that direct attached or hyperconverged. It comes in when we see it in the network environment. So that's what I wanted to present to you today. The idea that says that although you may at first just say, well, infrastructure is infrastructure and the processor and storage and all that kind of stuff, there are other characteristics that necessarily fall out of the way that you decide to secure these things. And the thing that I'd offer to you is that if you choose to deploy these things using an infrastructure that supports a network between the processing and the storage, and in particular a fiber channel network, there are some nice security side effects that come out as an advantage to that, and some that our customers have commented on. Yeah, I see you have your hand up. Did you have a question? Oh no, you're just enjoying the relaxing tone of my voice. So I think, yes, please.
That you are able to see, that is from an internal view versus an external view versus with the storage network diagram. So as an attacker, a great hat person, would I be able to see that from externally? That traffic signature?
The only way that you're going to get to see that is going to be if you have access not only to the raw data feeds that are going to be coming from the infrastructure, but also to the analytics engines that are capturing that and running the analysis on the back end, the things that are actually doing regression analysis. As a matter of practice, what we've found out is that most of our customers that have that management infrastructure air gap that or somehow put that on a completely separate infrastructure. The users have to get to the processor, but they go to great pains to make sure that the only connection between the processors and the storage devices is the data plane. So there's actually a lot of things that we could do to be even more automatic than we are today. Isn't it ironic? Isn't it ironic that in a day when we talk about automation, there are a lot more things that we could turn on from an automation viewpoint, but we don't want to do it because of security. And so in this case, there could be sort of like a deliberate nature to it. So the short answer to your question is that, I mean, your point is well taken and could actually go as a bullet pointed up here, is that the attacker would never have a chance to see the traffic patterns because they don't have the ability to the telemetry coming off and the management plane because, again, that's typically going to be air gapped. So yeah, that's a great point. Thanks for bringing that up. Yes, sir?
A lot of what you talked about its complexity, its different environment, its different data plane, sounds a lot like industrial control systems.
Yeah.
SCADA systems, PLCs. But what we're seeing with those is that an advanced threat is able to penetrate that language and that environment.
Stuxnet.
Exactly. Right. I mean, that was not a script key.
That's right.
But now it's available to script keys.
That's right.
How do you keep that same attack surface from being present on a SAN controller backplane?
That's a good question. So the way that we're doing it y'all can hear him, right? Okay, so for those of you who can't hear on the recording, you just have to assume it was a really good question. So there is, let me put on my gray hat for just a second and go after where you were being. My only point of attack to a SAN infrastructure is the HBA. because I don't have any other path that gets me into it. And presumably, let's say that the server has been compromised and I now have the ability to get in and I've compromised the HBA. Now that I've got that, what does the HBA have the ability to do? And that gets back to the conversation we had just right here. It turns out that with some instances, with things being fully automatic, the HBA can actually do quite a lot. Or put differently, there is a lot of things relating to automation that can be done on the infrastructure to benefit the HBA. For example, suppose that are you a SAN person, a fiber channel SAN person?
No.
So if I say something, there's this thing called a zone. And basically what a zone is on fiber channel is it's a set of strict enforcement that says this thing is allowed to talk to that thing. And you're not allowed to see anything else in the rest of that infrastructure. So what that means is that if you were to compromise that HBA, the only thing that you're going to be able to see is going to be the LUN, the storage LUN, that is currently associated with that HBA. You will not have the ability to go out and change your zoning, which is to say you can't suddenly decide that I now want to hop to the LUN that's next to that. And that's part of the fiber channel protocol. That's the way that it works. Now it turns out, if I can chase that for just one more minute, because this is really interesting, that was not intended to be a storage feature or a security feature. That feature is on there because in the day when we first started rolling out these storage arrays, who were the people that had to manage them? The people that had to manage the initial storage arrays were not networking people, they were storage people. And storage people had a lot of other stuff going on. So basically their charge, and the reason that storage infrastructures look fundamentally different is because even back in the late 90s when these first came out, these engineers said, I just want this stuff so that if I plug it in here and I plug it in here, the network is going to figure it out. No routing, no IP addresses, no subnets, no. I don't want to do any of that. I want this thing to see that thing. A side effect of that, and that's a really good point. I need to remember that point. The side effect of that is that we assign from a SAN management viewpoint what this is allowed to see. So you can compromise it and you can still see the thing out there, but the worst you're going to do is corrupt that LUN or lose connectivity to that LUN. You will not be able to go anywhere else. That's a good question. Does that make sense? Did I answer your question?
Yeah.
Okay. Any other questions or comments? If not, I think we have lunch now. Is that correct? But there's going to be, this is an initial discussion about security specifically as it relates to storage area infrastructures. After this, after lunch I should say, at 1 o'clock there's going to be a panel where we're going to be bringing up other people. I'll be moderating, but I'll probably not be saying as much. Probably relieved to hear that. But I'll sort of be steering between these different people who are going to give us some other aspects of storage, or I'm sorry, security. I keep saying that. But it's going to be from the aspect of the entire infrastructure and not one that's focused on the storage infrastructures we've done here in the last few minutes. Okay? Yes, sir?
Now I have a question.
Oh, good, good, good.
Okay, so I mean, I was trying to say what the panel said and what you had just said. More and more objects are in the cloud now.
Yes.
And, you know, the communication between two entities like NetApp or, you know, EMC, they don't communicate well unless it is on an IP-based thing, right?
Yes.
So how does that security play in what you said, because now the switch is gone?
Makes it better. Because what that means is that suppose, and did everyone get the subtlety in what he just said? Suppose I have different vendor storage arrays out there and I've somehow compromised one of those storage arrays. The odds are that same exploit is not going to work on the other person's control plane. If you go out and look at the controllers that are living inside these storage arrays today, they are vastly different because each one has their own sort of special way of doing different things like compression and security and LUN allocation and so forth. And so it's as different as saying your example earlier, the PLCs, that they have to be, it requires a special level of technical understanding of the device that you're attacking. The same thing is true with storage arrays, because we certainly haven't seen the point where that storage infrastructure is commoditized yet. So it's a great question. So even if somebody would get around and compromise the control plane out there, the other thing to remember is that since the network is sitting in the middle, even if you compromise this storage array, you're not going to be able to get to any other storage arrays, because one of the things that we certainly zone against, that's communication link, or certainly fenced, is that if you're on this array, we, as a matter of policy, absolutely prohibit you from talking to any other storage array that's sitting out there. with the caveat, unless you explicitly ask for it for the purposes of replication or load balancing or something like that. But typically that's not done between different vendors. Okay? Hey, looks like you are going to make an announcement.